In 2017, Marines and officials on Quantico, Virginia watched as a UH-1 Huey, the same helicopter that has been flying in some variant since the Vietnam War, took flight. There was one major difference with this flight, though. There was no pilot aboard. Retrofitted for autonomy, the Huey got instructions from a lightly trained Marine infantryman armed with a tablet, then headed out on a solo resupply mission, thereby ushering in a new era of flight technology. Sure, at this point we're familiar with tiny quadcopter drones that hover above sporting events, and even the large and deadly MQ-9 Reaper and others in its category. But this is different. Like driverless cars, this technology, in theory, could see humans in the passenger seat, but out of the loop. It's no coincidence that the military is testing driverless trucks and convoy vehicles at the very same time it's experimenting with these autonomous retrofits for passenger aircraft. Today, we're going to hear from Igor Cherepinsky, Director of Innovations at Sikorsky, a company now owned by Lockheed Martin Corp. As Director of Autonomy for Sikorsky, Mr. Cherepinsky was deeply involved in ongoing efforts to develop an optionally manned version of Sikorsky's S-70 helicopter, the rotorcraft on which the UH-60 Black Hawk is based. The first unmanned S-70 is expected to take flight sometime this year. Igor Cherepinsky, welcome to Left of Boom.
Thank you.
First of all, Director of Innovations is a wonderful job title. What exactly does a Director of Innovations do?
Well, so I think it's probably the most interesting and funnest job at Sikorsky. I basically get to run a group of very talented people who go out there and design all sorts of new things, be it aircraft, software, ideas, right? We kind of serve as an incubator for new and exciting things here at Sikorsky. We develop them to prototypes, flying prototypes, actually. We've done quite a few of those. And as things mature, we hand them off to the rest of the enterprise to develop into products, and we move on to the next thing.
That's amazing. Can you speak at all to some of the things that you're working on right now?
Sure. So obviously the most visible thing that I'm pretty sure most of your listeners have seen is our future vertical lift and X2 technology. Right, so a few years ago, we developed the world's fastest helicopter. It was a coaxial rigid rotor aircraft, dubbed X2. From that, you saw regular aircraft and SB-1 Defiant, which are both our future vertical lift offerings. They're in flight test today. And as we, again, got done with those prototypes, they've transitioned to the rest of the enterprise for productionization and, hopefully be replacing our own Black Hawk in the near future here. We've also worked on Matrix Technologies, right, which is the autonomy part of our technical pillars. With that, we've built a few prototypes. Again, the most visible one being SAR, Sikorsky Autonomy Research Aircraft. It's a blue helicopter with a whole bunch of neat sensors and software that we have been flight testing. We have actually let reporters come and fly it with a tablet because it's so easy to fly. So it's things like that.
Wow. So can you provide an update regarding the current status of Sikorsky Lockheed efforts to develop this optionally manned version of the S-70 helicopter? And of course, as I understand it, that's the platform that the Army's UH-60 Black Hawk is based on?
Yeah, absolutely. And really, before we dive into that, just really quick, I mentioned, Matrix Technologies and autonomy before. So for your listeners to understand, about, 6-7 years ago, as we were starting to look at what does autonomy mean to Sikorsky, and I should say before I had my current role of running innovations, I was responsible for technical leadership of the autonomy pillar. So we did a lot of soul searching, what it means for us, right? And especially back then, you saw a lot of drones. There was a lot of talk of, removing pilots and all that, sort of buzz. As we looked at products that Sikorsky makes, and again, keep in mind the S-76, which is, 11,000 pound, 9 to 12 passenger helicopter, the smallest thing we make. As we looked at those platforms, we said that, flying things with nobody on board is certainly interesting, but where is this technology needed most? And it's really safety, right? We looked at current state of rotorcraft in general. It's no big surprise that a lot of the rotorcraft accidents that occur today occur because of controlled flight in terrain and pilots encountering degraded visual environment. And it's really not for the lack of training, but because helicopters are very useful, right, in these kinds of missions where they are forced to operate next to obstacles in bad weather, right? Think of your typical EMS mission. where on a moment's notice, a rotorcraft is called to an accident scene, and the pilot has to deal with, chaotic accident scene and pick up injured people. Right? They don't really get much of a choice where to land, when to land. They have to go and do that, and they do it really well most of the time. But once in a while, the environment gets better of them, and accidents happen.
And I've heard helicopter pilots say that helicopters actually want to crash, like you're fighting the bird the whole time.
Yeah, it's they certainly like to say that. So I am a helicopter pilot, amongst other things. They are maybe a little more difficult to fly than typical fixed wing, but let's be honest, modern rotorcraft is very flyable with proper training, and most of the accidents that occur, they occur not because pilots didn't know how to fly or couldn't, quote unquote, fight their way through the machine. Most machines that Sikorsky and others make a nicely handling aircraft. It really is inability to see. Right, the number one cause is degraded visual environment. You didn't recognize there was a tree there. You started to come into landing zone. You didn't realize that there was a pothole, or you didn't see that you were drifting slightly to the left, and your wheel digs in, and the helicopter gets rolled over. That's the most typical thing that occurs. Right, which by the way is not too different from fixed wing aircraft. It just doesn't happen as frequently with fixed wing aircraft because you're far away from obstacles and you have time to recover. So that's what we wanted to address first and foremost with autonomy. We wanted to slowly take the journey of taking the pilot who is doing a lot of stick and rudder work on top of doing sort of mental math on the mission and say, hey, look, the machine can do most of the flying, if not all the flying. And machine can provide you sensors and automation to pick landing zones, avoid obstacles and do all these things that humans have a hard time doing. And you, the human, are really going to do what you do best, which is mission management. Right? Let's be frank. Machines are terrible, and they really can't do mission management. They can't design a mission. They can't figure out how to rescue somebody. That's what humans are great for. So what we set out to do is do this pairing between man and machine, where humans are really focused on the mission and how to do a mission, and they're telling the machine what to do, and the machine does it. And as maybe a little bit corny as it sounds, but think of Star Trek, right? You have this complex Starship Enterprise being run by a team of 6 people, and the reason why humans came up with that idea is because it's natural to them, right? So again, yes, it's science fiction, but our cultural references kind of draw towards that kind of environment where you can operate like that. So that's what we started thinking. That's what we set out to do. First, we demonstrate on the, again, Blue S-76, which was our research lab. And then the natural progression was to say, well, now that we're ready for a prototype, let's build a Black Hawk prototype. Because again, right, Black Hawk is one of the most built platforms out there. US Army has, over 2,000 of them. There are other folks that fly them a lot. So it made natural sense.
Right.
We got an older aircraft. It was actually UH-60A. It was, made in 1978. And the point there was to show that we can retrofit this, older vehicle with no digital flight controls and things like that with our kit and demonstrate the performance. So that's what we've done. The aircraft has been now flying for over 100 hours. We've done, basic system checkout, and we're progressively moving into more and more complex parts of autonomy this year.
Over 100 hours. Wow. So what comes next when you talk about that progression to different parts of autonomy?
We just got the perception system up and running. So LiDARs, cameras, and other sensors, so the aircraft can see. We're integrating what's called high performance computing. So it's, processors where a lot of our autonomy suite runs on top of the core autonomy and core flight controls. And that's the flight text that's going to happen next. And then we're going to work our way to actually demonstrating the fact that we can fly this vehicle with no pilots in it. And quite frankly, by the time we get there, it will be more of a, emotional than engineering demonstration. Because again, the system's full of fly-by-wire today. The crew on board that's operating the controls is doing so through the fly-by-wire flight controls and the autonomy system anyway for the last 100 hours. But these high-level modes. And there are missions that are useful to be able, to do without having human in harm's way, right? And I'm sure folks have heard the term, dull, dirty, and dangerous. So pick your either dull or dangerous mission. I'm sure lots of pilots wouldn't want to be putting out, fires over Fukushima nuclear reactor. But by the same token, a lot of pilots would rather do something else than fly routine cargo routes, as an example, right? So this is a case where having an optional pilot vehicle where you have an aircraft that you can easily, turn from having crew on board to not having to have crew on board without, pulling in computers, putting in actuators, and pulling in kits just by turning a switch. It's very useful to a whole bunch of our customers.
So you talked about that emotional component. Basically, when you take the human out entirely and you've got this aircraft in the air with nobody aboard, there's something inside of us that says, that's not right, that's not safe. It makes me uncomfortable. I mean, this is something that driverless car technology encounters quite a lot. I mean, can you speak to, the process of sort of reassuring and getting people comfortable with this technology and dealing with sort of that emotional development in the human relationship to these platforms?
Oh, absolutely. And again, this is where, I absolutely love the culture at Sikorsky and Lockheed, having, worked here for 20 years. It's really a culture of safety. So first and foremost, right, we want to make sure that everything we do is super safe. So to that extent, right, we've fielded quite a few complex fly-by-wire systems, which sometimes have the same question asked of them, right? Our 53K helicopters fly-by-wire, our Canadian Maritime helicopters fly-by-wire, and these systems are really there to help humans and ease quite frankly, the burden of flying that you referred to earlier. We have a whole bunch of very mature processes that the software and hardware goes through to make sure it's safe. And to help humans really deal with the emotional factor, we slowly work our way, right? As a very conservative, flight test organization, we very carefully and deliberately, work our way to these milestones like flying with nobody on board. But quite frankly, even first flights are very deliberate. Before this particular prototype flew, right, the S7 DLP prototype flew, we spent about 3,000 to 4,000 hours flying it in a full hardware in a loop laboratory. So we have a SIL in Stratford, which is essentially the entire aircraft, in the lab, and everything runs with the flight hardware in the loop and the simulation. So anything and everything that could go wrong gets tested. In fact, we break quite a few things in the lab on purpose, so that our first flights and flying afterward is born. Right? That's the idea here. So that's how we get through it. But it's still very emotional, right? I'm sure when we get to the milestone of flying this aircraft and we ask our safety pilots to step away and we'll start remotely and take it off, it will be an emotional event.
No doubt. And is there a date set for that event yet?
So as as funny things happened this year, yes, there was a date set, and things unfortunately are changing as we're dealing with our new and dynamic environment among COVID-19. We're obviously still working. We're working very safe, but that results in schedule changes. We're still hoping to hit partial milestone at the end of this year and then achieve full uninhabited flight sometime next year. But again, I can't predict the future in the current environment. It's hard to say.
Sure, understandably. So I wanted to talk terminology a little bit. So for the layman, could you talk about what the different terms mean when you're talking about unmanned versus optionally manned versus autonomous, and then the term that you've used several times already, fly-by-wire? What's the difference in the definition of all those terms?
Sure. So we'll start with the simpler one, perhaps. Well, maybe a simple one to me, but nevertheless. So fly by wire. Fly by wire simply refers to the fact that the human inputs, right? Let's use your car for an example, because maybe a little easier, right? The gas pedal in your car used to be connected to the throttle body of the engine with a cable. So every time you as a human being pressed the gas pedal, there was a cable and it opened the throttle and the engine would rev up. The cars still had computers in them, like cruise control, but if you hit that gas pedal really hard and you decided to speed the engine, there was nothing the computer could do, right? It was all on you, which is why the cars would have tachometers and all that wonderful stuff. Well, let's say you replace that with a sensor on your gas pedal that's going into the computer. Computer is doing some math, and it's commanding an actuator to actually open the throttle body. So now you can take that input from a human. You can maybe filter it a little bit so it's not so ragged. You can do limiting so you don't break the engine, things like that. So that is drive by wire, meaning that the input from a human being is going through the computer before going to the actuation system or to the things that act on your car. Right? Cars today, a lot of cars today have gas by wire, have brake by wire, right? In fact, people have gotten so used to anti-lock brakes, we don't think about it. Right? A lot of you younger listeners were never taught when driving a car how to pump their brakes because there's no need for brakes. We just rely on them because they just work, right? It's kind of like magic almost. Well, that is drive-by-wire. So fly-by-wire is very similar. We take pilot inputs with sensors, we run them through computers, physical and mathematical models, and then those commands go to the actuators. The benefit being is we can simplify the physics. Again, you mentioned that helicopters are hard to fly and fixed wing and actually so they are, right? But I can take someone who's somewhat familiar with aerospace and teach him to fly our core fly-by-wire system in about 20 minutes. I mean, they won't be great at it, but they won't crash, right? Whereas to fly something like a small Schweitzer, a small Robinson helicopter will take a lot longer than that because in the case of that helicopter, you have to do all the mental math associated with understanding physics and aerodynamics of the helicopter. With fly-by-wire, we hide some of that, right? And there's a lot of discussions and debates how much of it is appropriate to hide, how much is not. And it really is different in the civil and military markets, and we do that differently between the civil and military markets, but it allows that adjustability. It also allows safety, right? We can do things like envelope protection where you can't break the helicopter by making rapid inputs and things like that. So that's fly-by-wire. And then let's tackle the word autonomy because that's another term that's perhaps is misunderstood or misused, mispronounced, right? Its core means doing something autonomously, meaning by itself.
Right.
So we're really talking about a class of systems that can make a limited set of decisions. And what we mean by decisions is not some of the things that get touted in a driverless cars, right? The classic example is, right, with a driverless car, you're driving down the road, you hit the baby or the grandma. I'm sure your listeners, you have heard various variations of that, high-level decision. But yes, that's autonomy. No, we can't implement anything like that yet. I don't know that we can ever implement anything like that because of all the interesting moral implications of that and other things. But there's a whole bunch of, again, much simpler decisions that computers are pretty qualified to make. Again, back to the anti-lock brake system in the car, right? Your car makes a whole bunch of decisions with ABS, thousands of times per second as to where the wheels are slipping, where to apply braking power, and where to do all that. So that's very low-level autonomy. I mean, I know it sounds funny because people don't think that they own any autonomous cars yet, but in fact they do. There's a high degree of autonomy in everything we use today. We just don't think of it this way. So that's, in our aircraft today, there are very sophisticated autopilots that are making decisions on, approaches and landings and other things. Humans are obviously still supervising those. So as you imagine going up this decision tree, right, you can have the machine make more and more complex decisions. But that's in a sense what word autonomy means. And, at some point, maybe the machine can run a mission, maybe not. Again, it's a more an esoteric discussion today because systems like that don't really exist.
So for now, what is the current end goal? When you've got this technology matured to the point that you feel is possible at the moment, what decisions will still be in the purview of humans at that point?
Yeah, so the current end goal is that human specifies a mission. And let's think about a simple cargo mission, right? Human says, hey, I have cargo over here. Here's what it consists of, right? It's so many pallets. They need to go from here to there. And the machine says, I understand you have cargo here. It needs to get there, wherever there it happens to be. Presents a plan to a human being, very much like your GPS in a car when you're saying, hey, I want to go somewhere. You have a plan, take these roads. You get a plan back to it. It's a little more complex because it has takeoffs, landings, it has cargo pickups, cargo drop-offs, but it's a list of things that machines proposing to do. And you can modify it. You can say no, you can say yes. And if you say yes, machine's going to go do it. The neat part here is if there are obstacles, right? As the machine's coming in for a landing, as there's wires or there's a jeep on the landing. So the machine says, yeah, I understand that's an obstacle. I'm not going to hit it. Right? That's what you don't have to worry about. Whereas, that's different with today's, let's say, smaller drones to draw that distinction, right? Where you have a remote pilot, the drone is stabilized, it's very easy to fly, but the remote pilot is getting video and they're actively involved in actually controlling this vehicle and guiding it, right? And even some of these drones, it can follow GPS waypoints. Yes, it can follow GPS waypoints like another pilot, but it won't realize that there are obstacles. It won't react to changing conditions, changing aircraft health conditions, right? So that's sort of a typical first or second generation unmanned drones. I'm sure there are more sophisticated things out there, but for the sake of discussion, that hopefully is drawing a clear distinction.
At sort of the general non-classified level, can you speak about the actual technology that allows something like a Black Hawk to be retrofitted for autonomy or unmanned flight? What is the technology that allows that?
Yeah, so again, as you may imagine, it's a whole bunch of sensors, a whole bunch of computers, and a whole bunch of actuators. I mean, sounds kind of silly, but that's what it is. It's things that allow the pilot on board to provide input, or operator off board, or in the case of what we're doing was the optionally piloted aircraft. Again, if you go look at us having some reporters fly inside the aircraft, we'll give them the tablet. Well, it's the same tablet you'd use from inside the aircraft or outside of the aircraft. It doesn't kind of matter where you sit. You can actually go sit in the back of the aircraft if you prefer to sort of pretend to be a passenger and control the aircraft. You're making these high-level inputs of hey, take me here, do this, do that, and an aircraft is doing it. If you're more a pilot, you can grab things that look like cyclic and collective controls. Again, you're making inputs into a computer, but that's a little more familiar. It's a little more immediate. You can do that. Then we have a slew of algorithms, right? Again, it's math and physics running. Some of it is low-level math on how do I keep the air vehicle stable. Then some of it is more things that we call planners, for example, right? There's a piece of code that understands how to go from point A to point B without hitting things while respecting what the aircraft can do, right? Very important. We call it kinematically correct planning. Then there's sensors, right? We're processing multiple LiDARs, radars, cameras to perceive sort of the picture of the world. Things that humans do really well, right? If you're driving along in a car and you close your eyes, and don't do that, but if you did, you wouldn't immediately crash, right? Because you have a pretty good mental picture of what's where. You kind of keep tracking of all the cars. You're keeping this world state, the world model in your head. Well, we have something very similar for this autonomy system. And by the way, we're also putting a picture of that onto displays on pilots' helmets. So even as you're flying through the great visual environment, and you as a pilot can't see, the sensors are still working, the autonomy is still working, and it's telling you what it sees. So you can double check what it's doing, even though you're not actively flying, just as a benefit. Right, and then all of that produces control commands, right? It says move the cyclic here, move collective there, and there's actuators, right? The electric hydraulic things that make, swash plates move and blades move and tail rotors move. And it's basically a kit. You remove a whole bunch of the old mechanical flight controls, and you put in all of this stuff in, and voila, you have an optional pilot aircraft.
Fascinating. So something else that I've been following closely in parallel with what you all are doing is efforts to develop an unmanned fighter aircraft. So the Navy said earlier this year that it had converted an EA-18G Growler, which is a variant of the FA-18 Hornet, into an unmanned aircraft controlled by another manned one in the air. It made me curious in terms of what are the differences between developing unmanned technology for something like a utility helicopter and something like a fighter jet. Is it the exact same thing? They just look different in the air, or is it, a whole different set of challenges?
So it's very similar. And again, FA-18 is not our product, but we do know
Right.
folks in the Navy who work on that. But I'll tell you this, right? So on this Black Hawk project and a few other projects, we're working with DARPA, right? Defense Advanced Research Project Agency, under a project called DARPA Alias. You can Google it, you'll see a whole bunch of demos. But what we have done under this project is use the same system that's flying our Black Hawk, and we installed it in the Cessna Caravan. And we flew this Cessna Caravan, again, was single pilot operating, was an idea that can also be unmanned should any future customer decide to do so. So from this kit and actuation and computing perspective, the math is obviously vastly different between a fighter jet and a helicopter, but math can be changed out. Uh, a lot of the autonomy is very similar, right? You still have to plan, you still have to see, you still have to make some decisions. So it's very similar technology, and that kind of technology is being developed, in a couple of similar areas, right? Urban mobility folks are doing similar things.
To dream big into the future when it comes to autonomy and optional manning, what do you envision as the future of military aviation, say a decade or even 2 decades or more into the future? Do you imagine that there will still be sort of a mix of manned and unmanned platforms where the more complex missions, will still have a pilot at the controls? Or do you think that manned piloted aircraft are eventually going to go the way of the horse and buggy?
Well, so again, I may be biased because I already said I'm a pilot, even though I'm a pilot, but I'm still a pilot. I think having human eyes on the scene is an important part of what we do, right? Both physically and quite frankly morally, especially on the military side. So are we going to have purely unmanned aircraft? Well, yes, we are, right? Because we have them today, right? And there's no reason to kind of get into the moral questions surrounding some of today's unmanned aircraft. But if you think about what this technology brings, it's first and foremost it's safety, right? That's why we do this, and again, both military and civil world, it's going to make things safer. You will still, in a lot of cases, have to bring human along, in one capacity or another, right? We can have a discussion whether there'll be sort of a conventional stick and rudder in the cockpit in the future, maybe not. Right? Maybe there will be all touchscreen interfaces and other things where the human and the aircraft will be conveying to the vehicle the mission they want to do, but they'll still be in the aircraft. I'll tell you this though, in 10 to 15 years, I think every vehicle will have the flexibility of being operated with or without the human being, because there's definitely missions where you don't want humans in harm's way, but there's a lot of missions where you need people there for a variety of reasons. So that's, I think, larger vehicles like future vertical lift. And again, Army stated that FVL will be optionally piloted because again, it all has flexibility. Will all be OPVs, and you'll see a lot of companion vehicles which will be purely unmanned, right? So you can imagine like a future vertical lift aircraft operating was a whole bunch of companion, unmanned aircraft, and they also may be large, right? You're probably still talking about anything from 500 pounds up to thousands of pounds of an unmanned vehicle, and it'll really be more in a manned unmanned teaming kind of area where you have a few manned aircraft supervising a whole bunch of unmanned aircraft, and they're teaming together to perform the mission.
That's just an incredible visual. You've got the main aircraft and then sort of a cadre of unmanned systems, as their wingman, I guess is the term that I've heard thrown around.
Yeah, there's programs even called, right, Loyal Wingmen, where Air Force has looked at unmanned fighter aircraft, with manned fighter aircraft. So yeah, that seems to be the right mix. And remember, a lot of this really depends on making not just unmanned systems, but even these optional manned systems extremely safe, right? So one of the things that have been our sort of tenet, the reason why we like optional pilot aircraft is because there are those in the industry who would use the fact that there is no people on board as a way to relax the rigor of testing and standards of safety, right? And it's a slippery slope, because even though you may not have a human on board, any large aircraft still poses obviously certain dangers. So that's why we said we're not relaxing any of our rigors or standards. Any optional vehicle, pilot vehicle, will be designed to carry humans and tested as such. And then if they operate with no humans, you end up with this very reliable, uninhabited vehicle for the duration of that mission, because its next mission will probably be carrying humans.
When it comes to the technology and the external factors, would you feel safer riding in an unmanned rotorcraft or an unmanned ground vehicle?
Yeah, that's a tough call. And again, it depends what you mean by unmanned. The one that's deciding the entire mission, probably neither. I still want to have some direction control over one, right? Because as we all know, humans do need to have that ability. Otherwise, each domain has its own challenges, right? A few of my friends do work in the unmanned ground arena, and they have quite a few sets of challenges with the famous one. Hey, is it a shopping bag rolling down the road, or is it a real obstacle? Because today's sensors have real hard time telling the difference, right? So on one side you're going to have unmanned ground vehicles stopping for every piece of grass that happens to roll across their path, and on the other hand, if you ignore that, some really bad things can happen. So that's a difficult question to answer, right? The flip side, on like rotorcraft that operate close to obstacles, you have to be able to detect, tiny things like wires and rebar, which is very difficult to detect, but they can do a lot of damage. So each domain is challenging, and it's almost like a race of who gets there first.
Well, this has been an absolutely fascinating conversation. Thank you so much for all your insights and the update on what you all are working on. Thanks for being with us today.
No problem. Absolutely. My pleasure.
Thanks for joining us once again on Left of Boom. We had a few audio issues this week, and I appreciate your bearing with me as I work with remote guests during a pandemic. We're learning as we go, that's for sure. You heard Igor Cherepinsky discuss FVL, or Future Vertical Lift. That's the family of helicopters under development now to replace the Army's workhorse rotorcraft like the Black Hawk CH-47 Chinook and AH-64 Apache, among others. You can learn more about that, as well as things like Sikorsky's S-97 Raider, coaxial rotor system, and other efforts at lockheedmartin.com. We're going to be posting new episodes every 2 weeks, so please hit subscribe so you don't miss an episode, and let us know what you think about the show in the feedback section. Help us out by leaving a 5-star review if you can. We also still want to hear from you about future episodes. Who do you want to hear from, and what military hot topics would you like us to tackle next? Let us know by sending us an email at podcast@military.com. And remember to stay up to date on all the news that matters to the military community every day at military.com.